Hello, Mr. C here. Welcome to a video on one and two step equations. I think one of the best ways to figure these out is to just see a whole bunch of them and find the commonalities and differences between them. We're going to be using the property of equality throughout this video. And that's the property that says is if you have a true equation, okay, if you have an equation that's true, that can be solved, then you can do the same thing to both sides of the equation. I'm saying that loosely. You can either add, subtract, multiply, or divide the same amount to both sides, and it will remain true. So we'll use that each time, although many of these you can do in your head. Like, let's take a look at this first one on the left. X minus 4 equals 7. So you could probably do that in your head because what we're really asking is what number minus 4 is 7. You might quickly notice that it's 11. If you were to use the property of equality, though, something you're used to, you would add a value of 4 to both sides. And the reason you would add 4 is because you'll find an opposite here. Negative 4 and positive 4 add up to 0. And we're just left with the value of x. And on the right-hand side, 7 plus 4 is 11. Final answer, x equals 11. And so you can always check your answer by plugging it into the original equation to make it true, to make sure it's true, which is why you can do them in your head many times. Okay, on the right-hand side, let's take a look at this equation. Here, it might be easier to simplify first if you can. Notice on the right-hand side of this equation, you can simplify 1 minus 3, which will simplify to negative 2. And then our one step is to subtract 6 from both sides of the equation. And again, we're subtracting here instead of adding because 6 and minus 6 are opposites. And we get negative 2 minus 6x is negative 8. All right, so that's that. Let's take a look at some other examples. So here is something where we have multiplication and division. Notice this one on the top left says negative 4 times x, or negative 4x equals 16. So our inverse operation in this case won't be to add 4 because we won't get a 0. Remember, if we have negative 4x plus 4, those are not like terms. I'm sorry about the beeping in the background. So that won't get us anywhere. Instead, we want to make this just 1x, and we're going to do that by division. We're going to divide this side by negative 4, and the reason we're going to divide by the same number is any number divided by itself is just 1. That's just 1x. But whatever we do to the left-hand side, we'll also need to do the right-hand side. 16 divided by negative 4 is negative 4. There's my answer there. Okay, on the problem on the right, notice we again have simplification first on the right. 11 minus 5 is 6, and we have z divided by negative 4. This time my inverse isn't division, but rather multiplication, because it's already being divided by negative 4. My inverse is to multiply this side by negative 4, and likewise do the same thing on the right-hand side. That will cancel out here, or simplify out, and we'll get z equals 6 times negative 4, which is negative 24. That's my final answer there. A couple last examples where we get into multiple steps. Actually, I have 4 more. Here's one, 3/5 a equals 12. Now, you can do this as 2 steps, but you can also do it as 1. I'm going to show it as 1. So what it's saying is 3/5 of a is 12. You could draw a picture and reason it out, but I think probably the best way to do it is to multiply. The trick is to multiply any fraction times its reciprocal to get a 1. We're going to multiply this side by 5/3. That's the reciprocal of 3/5. And also multiply this side by the same number of 5/3. What will happen is 3 divided by 3 is 1, 5 divided by 5 is 1. We're left with just 1a. On the right-hand side, you can simplify first or later. So if you notice that 3 goes into 12 4 times, that'll save you some trouble. 4 times 5 being 20. You might pause and look at that one again, or try that one yourself to make sure you can get it out. Okay, on the right-hand side, we have 2 steps, but our first step is to simplify this time on the left-hand side of the equation. Those are like terms, so they can be put together. 4x minus 8x is negative 4x. And then this might look familiar. It's just like an equation we had before. If we divide by negative 4 on both sides now, negative 4's go away, and we're left with x is negative 4. All right, lastly, let's focus on some traditional 2-step equations. Okay, this first one on the left, 3x minus 12 is 24. Notice there's nothing to simplify on the left. Those are not like terms, so we can't put them together. But what we can do is we can first add the 12. So what we're going to basically do is combine the 2 steps we've shown so far. Add 12, that will give me a 0, but I also have to add 12 to the right-hand side, right? There's my side, right? That's my side of my equation. So negative 12 plus 12 is 0, but I'm left this time with 3x. 24 plus 12 is 36. And then the inverse for multiplying by 3, remember, is to divide by 3. 3 divided by 3 is 1. 36 divided by 3, my answer will be x is 12. All right, last problem over here. Notice again, on the left-hand side, we have two terms, but they're not alike, so we can't simplify them. This time we have a leading constant, 1, and it's positive. So I'm going to subtract 1 to get it to be 0. Also subtract 1 from the right-hand side. And I'm left with 3/5 a equals 7. 8 minus 1 being 7. This looks familiar as well. When we have a fraction, remember the trick was multiply by the reciprocal. I'm going to multiply this side by the reciprocal as well. 3's go away, 5's go away, and I think I accidentally deleted that. There we go. And on the right-hand side, this time nothing simplifies. So I'm just going to do 7 times 5 is 35. 1 times 3 is 3. That's an improper answer. If you wanted to change it to a mixed number to figure out what that meant, you could, but I think leaving it improper is a great way to go in algebra. So that's a little summary of 1- and 2-step equations. See you next time.